Are AI agents really learning properly? Welcome to this explainer. As autonomous AI gets smarter, as these agents run for longer periods, build memories, and use tools, the entire industry seems hyper-focused on just getting them to do more things and do them faster. But we've got to take a step back and ask ourselves, are we actually verifying what they're doing when we aren't looking? To start us off, I want to share something truly fascinating from our source materials today. Get this. An AI agent actually built a tool to inspect its own operations. Yeah, an AI named Mamushi built this tool from its own local signals. But, and this is absolutely critical, the AI doesn't make the final call. The AI just does the groundwork. It leaves the evidence. But a human operator always has to make the final judgment on whether to actually publish or use that work. It's a really brilliant division of labor.
So here's our roadmap for today. We'll quickly cover the AI auditing problem, meet Agent Watchbench, look at the local review workflow, discuss secrets and hostile inputs, check out the pre-release gate, and wrap up with limitations and next steps. Section 1. The AI auditing problem, and why we need to move beyond just making agents act.
Right now, as I mentioned, development is obsessed with action, right? Tool usage, browser manipulation, writing code. But when agents run autonomously for days or weeks, their sheer speed can actually amplify risks. Think about it calmly for a second. If an agent is running a long-term project, it might accidentally save a completely wrong conclusion into its memory. It could read an external article with a hidden hostile command and just blindly execute it. It might leak a secret API key into a report, or even decide an unverified prototype is ready for the public.
So getting the agent to execute a task is really just half the battle. After it finishes working, we absolutely must be able to verify what it learned. We need to see the evidence it left behind, and we need concrete proof that it actually respected our safety boundaries. Checking the work after it runs is just as important as getting it to run in the first place.
Which brings us to Section 2. Let's meet Agent Watchbench, a local-first observability and review bench.
Okay, let's dive into this. If we compare this to standard AI frameworks, the difference is pretty stark. Typical frameworks focus heavily on orchestration, what tools the agent has, its execution speed, how multiple agents interact. Agent Watchbench takes a step back. It focuses entirely on observability, the quality of the evidence left behind, and strict safety boundaries. It asks, did the agent learn the right lesson, and is it safe?
And to be crystal clear, this isn't some massive enterprise security scanner. It's just a small, read-only Python CLI or command line interface prototype. It literally just points at a local directory, reads the scattered files the agent leaves behind, things like daily logs or research notes, and produces one concise, readable report. And it does this without modifying any source files or running any of the agent's leftover commands.
Section 3. The local review workflow, turning scattered files into a readable report. To see how this works in practice, we can look at a synthetic ADA demo, and the pipeline is actually really seamless. First, your agent does its work and saves its notes locally. Then, you simply run the Watchbench scan command in your terminal. The tool instantly generates a clean markdown report. Finally, you, the human operator, read that single report and decide whether to publish, revise, or just pause the work.
And the markdown report itself is super actionable. It gives you the agent's learning signals, basically the actual lessons it took away. It provides ranked project ideas, highlights missing evidence warnings if the agent made unsupported claims, notes any safety boundary risks, and tells you if the project is actually ready to be published. It basically takes all that chaos and organizes it for you.
Section 4. Secrets and hostile inputs, redaction and neutralization.
Now, what's really interesting about this slide is how Watchbench handles sensitive data. If the agent accidentally pulls down a file with an API key, this lightweight secret scan feature finds it. It tells you the exact file path, the line number, and the kind of secret. But look at the value column. It completely refuses to output the actual secret into the report. It just redacts it. It warned you about the danger without spreading that danger into your audit logs.
Then there's the danger of hostile input. In plain English, if your agent is reading a GitHub issue or an external website, a malicious actor might have hidden instructions in that text specifically designed to hijack your AI. You might know this as prompt injection. It's essentially a trap left for your agent to blindly follow.
And this is where Watchbench's boundary rule comes in. It treats all external text and URLs as completely untrusted. The rule is simple. Summarize the intent of the external input so the human knows what it was about, but absolutely never execute the instructions inside it. Now, it's a fantastic safety boundary, but we shouldn't treat it as an absolute, impenetrable shield against all attacks. It's just a really smart layer of defense.
Section 5. The pre-release gate, which is our human-in-the-loop verification step.
Before anything goes public, Watchbench enforces a strict checklist. It checks that synthetic test data hasn't been contaminated with real user info. It verifies no secrets remain in the repo, checks that your CI tests are actually passing, and ensures your readiness stocks match what's actually being published. Again, this isn't a mathematical proof of safety. It's just a rigorous verification bench to catch human oversights.
Let's really hammer this point home, because it's the core philosophy here. The AI does the work. Watchbench prepares the evidence, but the human operator is the one who ultimately decides whether to publish. The system empowers human judgment. It doesn't replace it.
Finally, Section 6. Limitations and next steps. Let's keep our expectations grounded.
We need to strip away the hype and be very clear about what Agent Watchbench is not. It is not a constant real-time monitor. It doesn't guarantee safety, and it's not a high-end enterprise secret scanner. Also, it is strictly a pre-alpha proprietary prototype. It's a local, private-first tool, not a finished open-source product.
In fact, while it lives in a GitHub repository, it's private first. Pushing it public, publishing a package, or integrating it requires entirely separate, stringent human approval. It's being developed very quietly and carefully.
Which brings us to the main takeaway of this explainer. If AI agents are going to work for us long-term, just moving smartly isn't enough. We have to know what they learned. We need to see the evidence they left behind, and we absolutely need to know who approved it. Local, readable reports like Agent Watchbench are a necessary step toward that accountability. And that wraps up our look at Agent Watchbench. I highly recommend checking out the project's README and the synthetic data demo to see how this works in practice. And think about your own projects. What specific audit items do you need when running your AI agents? I'd love for you to share your operational auditing needs and feedback. Thanks for joining me on this explainer, and keep learning.